So, so I just got a question if we're doing review today. No. What we're doing today is MongoDB. I posted so the exam is Thursday, and I posted both practice exams, and I have a midterm review guide. Okay? If I was doing a midterm review, I would just crunch through this review guide. You don't need to hear me crunch through this review guide. You can read it. Okay? So make sure you go through this review guide, know that and be able to do this stuff. Okay? As I said the other day, look at the sample midterm. Obviously, there aren't questions from MongoDB because this is the first time I've taught the course using NoSQL and MongoDB, so you need to be up to speed with what NoSQL is, what the advantages and disadvantages of relational database management systems are relative to NoSQL. So down here I said MongoDB, but this covers actually NoSQL as well. So actually back here I had you need to know what ACID is, you need to know these theorems, what their implications are. You need to know these two important terms, horizontal sharding and eventual consistency. I did not, so drawbacks of relational databases and how NoSQL databases fix them. You also need to know why relational databases, what the advantages and disadvantages of them are vis-a-vis NoSQL. I'll add that to the review list. I'm not going to go over the types of NoSQL databases. We're only going to go over this type, which is a document store. You should at least know what the other types are, but that's the only type of question I would ask is I would give you a characterization of a NoSQL database and ask which of these 5 types it is. You can get that from the notes. So go over the notes, make sure that you get that. That is in my NoSQL notes. Today what we're going to cover is MongoDB, and for the most part, I've written a self-directing tutorial. So you can either start on your homework directly and use that tutorial to help you figure out how to formulate the queries, or my suggestion, you kind of go through my self-guiding tutorial document and familiarize yourself with MongoDB's query language and how it's structured. Okay? So that's what we're going to do today. I'm going to give you a brief introduction to MongoDB, but then I'm going to turn you loose. I do not expect you to leave because that's why I'm here. Believe me, this was my first time with MongoDB. I spent over a week getting everything together because it's not obvious how the queries work, okay? It's very frustrating when you first use MongoDB, and you could easily blow several hours on a query like I did, but hey, I'm here. I could get you over that pretty fast, okay? So that's why I don't want you leaving. I want you doing it here. Okay, so this is our last time with Mongo. We will be moving on after the exam to web programming, and I will talk to you about all that when we get to it next week, but because I want to give you all your time for the exam, make sure that we are going back to these pre-class participation activities. So you will need to be cognizant of the fact that starting next Tuesday, you need to complete pre-class activities again. Okay? And we're going to be going from quizzes to after-class activities, but we'll discuss that in class on Tuesday. Okay? So for today, I have posted a new set of notes called My MongoDB Notes. Kathleen Durant, I found her notes on the internet. She's at, I believe, Northeastern University. Has a nice set of slides on MongoDB. What I found is I could not find any really good coherent tutorial on MongoDB. I had to pull my stuff together from multiple sources. So I find sometimes it's useful to have multiple sources. So I thought her PowerPoint slides were the best resource I found on the internet that kind of in one place put down a lot of the knowledge you needed from MongoDB. But my MongoDB notes are what you're responsible for, okay? But hers, if you find something I said to be a bit hard to follow, maybe her notes can help you. And of course, there's plenty of tutorials on the internet, and Stack Overflow and the like, but hopefully you can get it from what I say. Okay, so what I'm just going to talk about is the design principles for MongoDB and actually show you quickly what a sample MongoDB looks like. So this is actually a sample, very simple Mongo database with 5 documents. So MongoDB uses JSON. Okay, it actually stores things using Bison, which is binary JSON. But the way you interact with the DB shell is with JSON. So every document is a JSON object. We have 5 documents here. You can see there's key value pairs. You can see that you can have embedded documents. So here, size is what we would call a composite attribute. Okay, and we have combined the attributes, the simple attributes that make up that composite attribute into an object, which MongoDB would call a document. Okay, so 5 documents. We've labeled each attribute field with its name. So item is the name of a field, journal is its value. Okay, so that's what it looks like, a very simple Mongo database. Okay, a slightly more complicated one okay, here is one that has an array, so in stock for a journal, and it's being kept at 2 warehouses, warehouse A with a quantity of 5, warehouse C with a quantity of 15. So these are embedded, what are called embedded documents. But what it really is it's in stock is an array or list of 2 documents. Now in a relational database, this would be in a separate table. Warehouse would be a separate entity. Okay, but here that entity is in effect kept as a set of documents. The tuples, instead of being stored in a separate relation, are being stored with the item named journal. Okay? So you might think of this as a multi-valued attribute, or you simply might think of warehouse as being something of a weak entity. It depends for its existence in some sense on item. Okay? So like everything else, MongoDB is trying to eliminate expensive joins. And the way it's doing that is it's embedding things like those warehouse documents. So basically, when you have one-to-many relationships involving weak entities, so with that journal, it stored the warehouse entries. So instead of putting those warehouse entries off in a separate relation, we're treating warehouse essentially as a weak entity. We're saying that many warehouses can store this single item. It's a one-to-many relationship. Okay? So we're embedding all those entries for the warehouse with the item, and we eliminate the need for a join. All the information associated with the journal item is stored with the journal in one big document. Okay? Now, let's go back and look at that warehouse for a moment. What we see is that the warehouse name is duplicated all over the place. That's the drawback. If we change the name of the warehouse from A to D, we're going to have to change 3 different documents in order to keep the data consistent. Whereas in a relational database, we would only change it in one place. Okay, so that's the trade-off, is we are duplicating or replicating data. Okay, but that's going to lead hopefully to faster performance because we're not doing expensive joins. So MongoDB works really well for these one-to-many relationships involving weak entities. Okay, entities that depend for their existence on another entity. Project and subtask. Okay, subtask is a weak entity. It wouldn't exist without a task, and it's tightly tied to that task. It's really not tied to anyone else's task. Your exams are tightly tied to you. Okay, unless you cheated. Kidding. So the exam you did is only you. So why not just have the exam be with your record rather than in another relation? Okay, it's a weak entity that's tied only to you. So that's where MongoDB works well, for those kind of relationships where you're only tied to one person. The warehouse relationship is not a good example because it was in multiple places. Okay, multi-valued attributes. MongoDB represents multi-valued attributes as an array or list. Okay, array and list are synonyms. When I say array or list, I don't mean one structure or the other. I mean a list. So all multi-valued attributes can be placed together. So for example, I think I have, do I have quizzes? Nope. What's the thing that is? Let's see. Okay, here. Tags. Okay, multi-valued, you can have as many as you want, and they're all stored with the document. In contrast, in a relational database, you'd have to put that in a separate relation. Okay, composite attributes. I already showed you a composite attribute, how I was able to group all of the simple attributes together in one document. Okay, works well with supertype subtype entities. You just add a type field that says what the type of the entity is. So rather than having one table that factors out all the common attributes and having that be the supertype and then having some subtypes. So for example, you have personnel at a university. Rather than having one supertype that's person with like an ID and then having a bunch of subtypes for professor, student, staff, and each of those is a separate relation, you just have a single kind of person document with a type field for professor or student or staff. So there's none of this separation of supertype from the subtype. You just use a type field to indicate what the type of the entity is. And then you just have everything in one collection. Okay, and a collection is a relation. So here, this right here is called a collection. DB is always the start of the command in the Mongo shell, dot, and then the collection name. So here the collection name is inventory. Collection corresponds to relation in a relational database. Okay. Ah, forgot something. I forgot. I'll have to fix this. I used braces, and because they're a less than sign, they got eaten because it thought it was a tag. So I have to fix that. Let's see. You got that. Okay. Don't have to worry about this anyhow for the tutorial. Okay, so a collection, unlike so in relational database, you have to create a table using the DDL. So before you can use a table, you have to create it. In Mongo, you can just, the first time you have an insert operation, it creates the collection for you. You don't have to have a separate data definition language. So in Mongo, you don't really have the notion of a data definition language. You just have the notion of a DML for data manipulation language. So if the collection doesn't exist, you do an insert command, it creates the collection for you. And you don't declare the schema type, meaning you don't say, well, this has an item field that is a string and a QTY field that's an int and a size field that is blah, blah, blah. You simply provide key value pairs. You don't have to even have the same type. I could have an item that had the number 3 or an item that is a document. So the types for the attributes don't even have to be the same. Okay, now that would be pretty uncommon, but it does happen. Okay, so you don't have to declare the schemas. There's no DDL necessary in MongoDB. You can just dive right in. And if you want, you can, because you will have to do this for the homework assignment, for each question, you need to put your question into a .js file. That stands for JavaScript. Don't worry. There's nothing about JavaScript here. Okay, it's a MongoDB command, but you're going to put your commands into a .js file, and then the load will execute it, just like you could do a load in the MySQL shell. Okay. Let's see. When you do a create, one thing that I want to just point out. So let's go to the top. Okay, so when you create a document, MongoDB automatically creates an attribute called _ID that has a value, a unique key. So you always have a primary key in a document, and it is the _ID field. You are allowed to assign a value to it if you want. So if you want, you can assign a value to it, but if you don't care what gets assigned, MongoDB will do it arbitrarily. Okay, so if I just actually, for a moment, I will copy this command, and I will go to the shell that I suggested. Of course, that's probably where, there we go. We'll go to this page. Here's an interactive shell. Wow, slow, okay. Type it in, and you can see these are the object IDs that were given. So if I say db.inventory.find, going to say item journal. Yeah, there we go. You can see that the ID field is there with this automatically generated field. Right here you see it too. Okay, so the ID field is always there. Any questions about what I've covered so far? Okay. What I want you to do, the rest of it, I have basically written something so that you can do create sample collections. I have shown you how to do find operations on different things. I can see that I didn't get all of my, I'm going to have to do some quick editing while I turn you loose because I see that HTML ate some things. But I'm going to turn you loose, and what I would like you to do, so if you go up here, the very first thing, if you click on this link, it will give you access, like you just saw, to a MongoDB. If you just click, you can now start executing MongoDB commands. So you don't have to create your own MongoDB. Okay? So I am going to turn you loose. Like I said, I need to fix this document quickly, but it takes you through insert, update, find. So as I said, feel free to either start doing homework 6 or feel free to do my document. I suggest doing my document first so you get a feel for it. But if you want to start the homework first, that's fine too. As I say, I